Chapter 2 deals with functions and their graphs. That's a big title, functions in general, and graphs, of course, it's part of a function. Now, first let's define a function. So the notation, we know the notation, but I assume that we have to review everything. So first of all, notation is f of x. Some students I hear, they say f times x. No. So this is red, f of x. And this is the same thing with the y value. So the function is entitled or named f, which is the dependent variable, and x is the independent variable. This depends on this, which means always the independent variable is on the x-axis, and always the dependent variable is on the y-axis. Now, let's define a function. What is it? So a function is a correspondence. What does it mean? It makes x correspond to only one y value. What if I have a situation in which x corresponds to 2 or more y values? Is this possible? Yes, but it's not a function. It's called a relation. Let's illustrate the difference between these two. So what is the difference? Well, the difference is that both can happen in real life. Both can happen in real life. But the difference is the graphs are different. The representation is different. So here's an example of a function, and this will be an example for a relation. Let's say I have a set of x values. This is what we normally call domain. And I have a set of y values, which we always call, anyone remembers how we call this? It's okay if you don't. I'm going to write it anyway.
Range?
Yes, excellent. Thank you very much. So now if the correspondence is like this, so this is a value, I'm just going to put some numbers, 4, 5, 3, 2, even this, let's say 6, corresponds also to 2. This is a function. Each x value corresponds to only one y value. But this one is not a function. It's sufficient to show that one x value corresponds, let's say 2 corresponds to 0 and 4. So this is a relation. This set is also called domain. This set is also called range, but they are the domain and range of a relation, not a function. Okay, I want to look at a few graphs before we continue. chapter opener on page 220, no, 220, where is my, okay, it's 232. Okay, I'm sharing my screen. Why is it important to know what if a correspondence is a relation or if a correspondence is a function? Because we are going to create functions and create models, and we have to understand how to graph those functions. And if it's not a function, we need to know how to, not in this class, however, in another class, we learn how to graph those who are not functions. Okay, so here's the first question for us. So let's look at these graphs, 57 through 64. Can anyone tell us or choose a function from these graphs? Let me explain one more thing before we do that. When we graph a function, this is a function. This is sort of an ellipse. The ellipse is not a function. How do I know? It's called by the vertical line test. What is the vertical line test? So if I draw vertical lines, in other words, for one x value, we've done this before, when we read from graphs, for one x value, I read only one y value. For this x value, by the vertical line test, so for this other x value, let's say this is x1, this is x2, I read the corresponding y2 and y1. But look what happens here. By the vertical line test, for x1 here, look what happens. I read two y values. That's why this is not a function, not a function. And we call it relation. This is a function by the vertical line test. So back to our graphs. So from 57 through 64, can anyone give us an example or choose an example of a function first?
You said 57 through 54?
Yes, 57 to 64.
See?
If anyone can choose one and say, this is a function, and I'll say, yes, you're right, or I'll say, no, it's not.
58.
58 is a function or is not?
It is.
By the vertical line test, for this x value, I have this y value, 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 this y value. Is 58 a function?
Yes. No.
For the same x value, I can read infinitely many y values. So let's take a look at this. So the graph is this. I'm going to pick a number, let's say x equals 4. So when I graph it with what I like to call bubbles.
It's horizontal. That's right.
That's okay. That's okay. It's a very, even, it's good that we make mistakes. Otherwise, you don't need me. Yes, right? So when x is 4, y is -2. And it's also 0. And it's also 3. And it's also 7. easier to see this. 4 belongs to -2. 4 belongs to 3. 4 belongs to 0. 4 belongs to 7. So by the vertical line test, this is not a function, this is a relation. You really helped me explain this and give the correspondence on the side, which makes it very easy to understand. Never say sorry, Brad, please. You really helped us. Okay, can anyone choose a non-function now, a relation from these graphs? Page 233.
Would 59 be a relation?
Correct. 59 by the vertical line test is a relation. Can anyone again choose one function? A function, not a relation. From 57 till 64. Anyone that is a function. One example, please. Any.
61.
61 is a function. By the vertical line test, every vertical line, thank you so much, will cross the function graph, the graph of the function in only one point. The same thing with 63, the same thing with 64. Perfect. Okay. Moving on. Now, I would like us to pick a graph from here, because graphs, when we look at the graph of a function, these are all functions now, when we look at the graph of a function, we will be asked a lot to say a lot about the function. We are able to read a lot from a function. So let's choose one. I will graph it on my paper quickly, and then we will read from here, but I have to graph it on paper. So please choose any of these functions. Are they functions? Yes. By the vertical line test, they're all functions, all of them. So let's pick a function and answer a couple of questions. Anyone would like to pick a function?
64.
We want to pick, we can't. We have to pick from, my apologies, from 77 till 86. From 77 till 86.
All right, 77.
77. Perfect. Okay, so here's the graph of 77, and this is on page 233, and I'm going to graph it. Okay. Good. Very good. So here's the graph. Of the function. Yes, we already established the function by the vertical line test. So we are asked a few questions. They are asking us to find the domain. Question part A, domain. What is the domain again? The values of x. We are given the graph. We are not given the function. And from the graph, I am able to establish the domain. What x values can be plugged in this function, or for what x values I can find the y value. That's all it means. These arrows signify the fact that the function continues forever. And it will not continue like this, because it will not be a function. It has to go further and further away from the y-axis, further and further away from the y-axis. And it has arrows, meaning it goes on forever. What are the possible values of x? Anyone can guess? What are the possible values of x? Anyone, please?
-3 and 1.
It goes on forever. It goes on forever. In other words, if I'm here, will I find a y value? Yes. If I'm here, will I find a y value? Yes, as long as I extend it. If I'm here, it's 0. If I'm here, yes. 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 So what will be the domain of this function?
Infinity?
Say it again, Vali.
Is it infinity?
Very good. Everything. Everything. There is nothing that impedes this function. It can go on forever. So if you ask me, okay, let's say I extend it, and if you ask me for x equals 4, can I find y value? Yes. If I extend it further because of the arrows, you can say, can you find the y value for this? Yes, of course. As long as I extend it, it goes on forever. So the domain of this function is indeed everything. We read the domain on the x-axis. The function exists for any x value. Now, question part B, range. The range is read on the y-axis from the lowest y value till the largest y value. If you think that we can read better from the graph, let's do that. So we chose this graph, and we want to determine its range. Remember the arrows. Here there are no arrows. So this is very clear where domain and range, we can choose a problem like that as well. But here the domain is, obviously it has arrows, it goes on forever. So that's why the domain is everything from -infinity to infinity. But now we're asked to find the range from the lowest possible y value till the largest possible y value. Can anyone identify the range for 77?
-4 to infinity?
Excellent. The range indeed. Do I put a bracket at -4 or a parenthesis? If the point exists, I have to put a bracket. If the point is an open point, then I have to use parenthesis. So it was indeed -4 to infinity. But do I use a bracket or do I use a parenthesis? A parenthesis
Would it be a
means,
bracket?
yes. A parenthesis means a point like this. A bracket means a point like this. Perfect. Okay, next question. Now we're asked, we established the domain and range. Now we're asked more questions about it. They're asking us now to find the x and y intercepts if they exist. Part C, x and y intercepts. Good, so let's look at the function again. And let's identify the x-intercept or x-intercepts. And I would like them as an ordered pair format. Can anyone look at the graph and say, I see this as the x-intercept? Please. We graphed using x and y intercepts before, so we know where they are and what they represent. Can anyone identify x-intercepts for us, please?
-3, 0.
Very good, that's the one. -3, 0. Perfect. And
1.
it's an ordered pair. 1, comma,
0.
perfect. Excellent. These are the x-intercepts. So x-intercepts. Can anyone identify the y-intercept?
-4.
Y-intercept. It has to be on the y-axis.
0, -3.
Yes, it's right here. 0 for x, -3 for y. Very good. Perfect. Any questions? Please stop me if you have questions. In part D, they're asking us to determine these values. F of -2 and f of 2. First of all, let's explain what it means. We discussed this with the graphs before. This is not new. If I'm asked to find f of -2, it means that I am given that x is -2. I'm told that. It's given. If I'm asked to find f of 2, I am told that x equals 2. And as we did before, all I have to do is draw or imagine I draw a vertical line, as I just did with some other values, at -2. I see it crosses the graph at this point, and I have to read the y value. We're not going to read from my graph. And at x equals 2, so this was the line, the vertical line, x equals -2. And here I have x equals 2. It crosses the graph in this point, and I read the y value. We're not going to read from my graph because it's not exact. So we're going to go back. Can anyone draw or imagine that you draw a vertical line at x equals -2 and tell us for that point what is the y value? And that is the same with f of -2.
-3.
-3, perfect, thank you. Now at x equals 2, I draw or I imagine I draw a vertical line at 2, and this is x equals 2. It crosses the graph here. I need to read the y value.
-4.
You mean +4, correct. Very good. So now, always remember, -2, comma, f of -2. Yes, it happens to be -2, -3. This is -2, -3. So for x equals 2, f of 2, f of 2. So this obviously means 2, 4. Please, this is very important on how to read from graphs. Good. Do we need another example, or is this clear? Can anyone just give us the domain of this function and the range afterwards for 81? Can anyone give us the domain? The domain is we read on the x-axis.
1
On
or
the
0
x
to 5.
is 0 to 5. Awesome. So for 81, the domain is 0 to 5. What do I put at 0 and what do I put at 5?
0 is -1, 5 is +5. It's 5, 5.
I meant
Right.
I meant brackets or parentheses first.
Brackets.
At which one?
for 0 and then parentheses for
At 5.
5.
Excellent. Good. Now we are ready to identify the range. We read the range on the y-axis always, from the lowest y value till the largest y value. So for 81, can anyone identify the range for us?